Tonight's notes are on determinants and Cramers rule. Each square matrix has a real number associated called its determinant. The determinant of a matrix A is denoted by either DETA or by the following symbol. For a 2 by 2 matrix, the determinant is the difference between the product of the diagonal down entries and the diagonal up entries. For a 3 by 3 matrix, you're going to recopy the first two columns behind the matrix, then find the sum of the diagonal downs and subtract the sum of the products of the diagonals up. Let's look at two examples. So to find the determinant, I need to take the sum of the diagonals down, which would be negative 12 times negative 4, and I'm going to subtract that by the diagonals up. This is going to give me 48 minus 30, or 18. For the second one, my first step is to recopy the first two columns. And then I'm going to do the same thing. I'm going to find the product of the diagonal down. So my first one is 1 times negative 2 times negative 4. And I'm going to add that to the next diagonal down, which will be 0 times negative 1 times 0. And I'm going to add that to the third diagonal down, which is 3 times 2 times negative 3. We know we're done doing the diagonals down because there are no more diagonals going down. That will give us 3 terms in each. I then need to subtract this by the sum of the product of the diagonals going up. So now I start with 0 times negative 2 times 3, and I'm adding that to negative 3 times negative 1 times positive 1, and to my third diagonal, which is negative 4 times 2 times 0. So if I want to go through and simplify, then I end up with 8 plus 0 minus 18 in the first set of brackets, and that was being subtracted by 0 plus 3 plus 0. So I end up with negative 10 minus 3, or a determinant of negative 13. Please look at the next page. We can use the determinant to find the area of a triangle. Given the vertices of a triangle, the formula for area is plus or minus 1/2 the determinant of the vertices, with the final column being ones. The plus or minus in this case is meant to take whichever sign is needed so the answer is positive. Do not say the answer is both positive and negative. Area is always positive. And don't forget to label your answer as units squared. So for our next example, we are going to find the area of a triangle with the following vertices. So to set up our problem here, the first thing I need to do is find the determinant. So my matrices would be 1, 2, 4, 0, and 6, 2, with a final column of ones. And because I'm finding the determinant of a 3 by 3 matrix, that means I need to recopy down the first 2 rows. And then I can begin looking at my products of my diagonal downs and my diagonal ups. So the first one gives me 1 times 0 times 1 plus the second diagonal, which is 2 times 1 times 6 plus the third diagonal, which is 1 times 4 times 2. And this is going to be subtracted by my diagonal ups. So we start with 6 times 0 times 1, and that'll be subtracted or added to our second set of diagonals, which is 2 times 1 times 1, which will be added to our third set, which is 1 times 4 times 2. So if we try and simplify here, I get 0 plus 12 plus 8 in the first set of brackets, and that's subtracted by 0 plus 2 plus 8. So we get 20 minus 10, which gives us a determinant of 10. Now I need to plug this into the formula for area, which was plus or minus the determinant. So because the determinant is already positive, I want to multiply that by a positive 1/2, remembering that I cannot have a negative area. So we get 5, and then I'm going to label it with units squared. Please try to do example 2 on your own, and then look at the next page. The next thing we're going to be looking at is Cramers rule. You can use determinants to solve a system of linear equations. This method is named after the Swiss mathematician Gabriel Cramer. Cramer's rule uses the coefficient matrix of the linear system. So this is made up of the coefficients in front of x and y in both equations. Using a 2 by 2 system, we're going to let A be the coefficient matrix of this linear system. If the determinant of A is not equal to 0, then this system has exactly one solution. That solution is represented by the determinant of the following matrix divided by the determinant of the coefficient matrix, and y is equal to the determinant of a different matrix divided by determinant A. Notice that both of these matrices leave out the coefficients that include the variable you're solving for. The first one is missing A and C, which were the coefficients in front of x, and the second one is missing B and D, which were the coefficients in front of your y. Let's look at using Cramer's rule to solve the following system. The first thing we're going to do is set up a coefficient matrix and solve for the determinant of A. For this matrix, I am going to be using the coefficients in front of x and y. And in order to find its determinant, I'm going to take the product of the diagonals down, and I'm going to subtract it by the product of the diagonals up. This gives me negative 32 minus 10, or negative 42. Next, I'm going to go and solve for x. So I have x is equal to, and I need to find the determinant. So I'm going to put it inside of the appropriate matrix. Notice for this one it says that I'm using E and B. So I'm using the constant on the right side of the equation and the coefficient in front of the y. And I'm doing the same thing for the second equation. And this is going to be divided by the determinant of a, which we have just solved to be negative 42. So now I need to find the determinant of the numerator. So I have 2 times negative 4, and that's going to be subtracted by negative 10 times 5, and this is all still over negative 42. So I get negative 8 plus 50, which is a positive 42, which gives me an answer of negative 1. Next, I need to do the same thing, go through and solve for y. There's a different matrix this time. This time it is using the coefficients in front of x and then the constants on the right side. So we have 8 and 2 and negative 10. And again, I'm dividing it by the determinant of a, which is negative 42. So if I look at my diagonals down, I get 8 times negative 10, and that's subtracted by the diagonals up, which are 2 times 2. And this is still over negative 42. So I get negative 80 minus 4, which gives me negative 84 over negative 42, or positive 2. Because we're solving a system, remember that your answer should be an ordered pair. My x was negative 1, my y was 2. And that would be our solution. On the next page, you'll see using Cramer's rule using a 3 by 3 system. We will talk about that example tomorrow in class.